Hello, PVHS students. I want to put this lesson in a video because we've been having a lot of absences lately towards the end of the year. This lesson is titled ID Functions from Numerical Patterns. So we just we just finished creating particular equations, right? Particular equations after we understood graphically that are the graph of this function is linear. So we assume it's linear because it looks like it has a constant slope. It looks like a line. So we assume it's linear. So we want to use the general equation y equals mx plus b. And then we went through the process of finding the particular equation. However, what if all we have is a set of data? There's no it's not graphical, it's not a picture. So how can we can still determine that this is uh, linear. So if you notice on the left side, from 2 to 4 I add 2, and that's from 4 to 6 plus 2. Oops, I also add 2, right? And same way from 6 to 8, I add 2. And we want to go through the entire data set because you never know, it might switch up, so we want to be absolutely sure. So if the entire data set, I'm adding 2 on the left side. Okay, so this is so that's interesting, I hope. Okay, and so now what about on the right side? Well, from -3 to 1 I add 4. From 1 to 5 I'm also adding 4. From 5 to 9 I am also adding 4. And like I said, you have to check the entire data set because I might throw you a curveball on the final if you don't. You want to be certain. Anytime you do anything, you want to be certain as you can. So this is called the add property of linear functions. Add property of linear functions. So what does that mean? That means that A, this function is linear. B, use the general formula. Formula. Let's go down. Use the general formula y equals mx plus b, correct? And then we go through the process that we went through here. And if you notice, look at I've highlighted these two sets of points. 6, 5, 4, 1, 6, 5. Let's highlight 4, 1, and 6, 5. So this is actually the same data set. However, here we only need 2 points because we have 2 unknowns. So we need 2 equations, or we need a slope formula to create the particular equation. Here, because we see that it's linear. However, here we can't immediately, it's not immediately clear that it's linear unless we use the we notice the numerical pattern called the add property of linear functions. Okay, so then we're going to use y equals mx plus b, and we're going to use m, the slope equals, right? What is it? Y2 minus y1 divided by x2 minus x1. Well, where's my x1 and y1? So x1 comma y1 you can choose any 2 points here. Let's choose the same ones that the graphical example chose. And then you don't even have to do this example over again, right? You can work on a new example. So x1, y1 would be 4 comma 1, and x2, let me just copy this part. Thank you. So x2 comma y2 would be 6 comma 5. 6 comma 5. And then, so this is, this is the same same process as the example I went for in class. In fact, it's the same exact function. Okay, so I'm not going to go over the example again because we've already went through it in class. Okay, just the only new information is here is when you see a data set and it you can understand that the pattern is add, then that becomes then you can feel confident that this is a linear function, and you can go about using the methods that we learned in class to find the particular equation. Okay, if you have any questions, I'm going to be circling around while you're watching this video so I can help you a little more closely, personally. Okay? All right, well, thank you very much for watching, and now do your homework.